question 9.18 from the pre-lecture reading homework is a pretty good test to basically go through everything that we've covered in this chapter. Can you look at the number of bonding domains around a central atom, and then based on that determine the hybridization of the atom, and then determine ultimately what are the bonds, what are the orbitals used to form the bonds we're looking at. And that's all that this question is asking. It's asking you to find what would those orbitals be overlapping to form each of the bonds indicated. And so if we look at this first hydrogen here, right, hydrogen, it'll always have an s orbital. If we look at this carbon in the triple bond, this carbon has 2 electron domains. Because it has 2 electron domains, it will be sp hybridized. 2 electron domains, an s orbital plus a p orbital gives me 2 hybrid orbitals that are sp. The same with this carbon here, I will also be sp hybridized. Nitrogen has 3 electron domains, so to obtain 3 electron domains would be trigonal planar, and I would be sp2 hybridized. The oxygen also has 3 electron domains, 2 lone pairs of electrons and the double bond, so oxygen will also be sp2 hybridized. The oxygen down here has 4 electron domains, 2 are bonding, 2 are non-bonding, so with 4 electron domains we would be sp3 hybridized. The sulfur has 4 electron domains, all bonding domains, so sulfur would also be sp3 hybridized. Both of the oxygens, just like the previous oxygen in a double bond, will be sp2 hybridized. And then the last carbon has 4 electron domains, and based on that, right, it would be sp3 hybridized. So now we have to figure out the orbitals that are used for the bond that's observed. And so in the first case, this bond A between the hydrogen and the carbon would occur between orbital overlap between an s orbital from hydrogen and the hybrid sp orbital from carbon. For B is asking for the sigma bond, which is the single bond. It's the first bond that would be formed between those 2 carbons, and that first bond that would be formed would be between hybrid orbitals. So each carbon is sp, so that bond would occur between sp and sp orbital overlap. Bond C occurs between, again, an sp hybrid orbital on carbon and an sp2 hybrid orbital on nitrogen. Bond D, and now it's asking for the pi bond of bond D. The pi bonds can only occur between atomic p orbitals, the overlap between 2 atomic p orbitals in this case. So you'll notice both the oxygen and the nitrogen are sp2 hybridized, right? That came from an s plus 2 p orbitals. We know, however, though, we have an s orbital and we have 3 different p orbitals. You did not hybridize one of those p orbitals, so that means on both nitrogen and oxygen we have a p orbital left, an atomic p orbital left that's unhybridized. We're going to use that for our pi bond. So for the double bond in D, that would occur between p orbital from nitrogen overlapping another p orbital from the oxygen. Bond E, we're back to hybrid orbitals. Nitrogen would be sp2 overlapping with an sp3 orbital from oxygen. After E, we have F. F is going to be an interesting case because, again, the central sulfur is sp3 hybridized. So that means to form that sulfur at sp3 hybridized, we've mixed together our s and our p orbitals now. My only remaining atomic orbital from sulfur would be a d orbital. So for sulfur to form that pi bond between oxygen, it would use a d orbital from sulfur and the remaining p orbital from oxygen. For bond G, we're back to the hybridization. We're using hybrid orbitals, right? For all of our sigma bonds, it's only the pi bonds would we use atomic orbitals for. So bond G, the central sulfur is sp3, and it's bonding with an sp3 hybridized carbon. And then the last one would be just like our, well, actually it would not be like our first one because we have sp3 hybrid carbon, and that would be overlapping with an s orbital on hydrogen. So that should be the correct assignment for each of those orbitals and each of those bonding interactions that we observe.